So we're going to continue this problem and try and find our eigenvectors v. We've got our eigenvalues. We're trying to solve this equation for v. So we've got a, which is equal to 2, 2, 5 minus 1. We're going to let our vector v just be equal to x, y, and then we want to find x and y such that this equation is true, and that's equal to lambda xy. So we've got two values of lambda, so we're going to find the v for minus 3 and then the v that satisfies minus 4 as well. Right, so when we're looking at lambda equals minus 3, we get 2x plus 2y is equal to minus 3x. That's just using matrix multiplication. And we get 5x minus y is equal to minus 3y. And both of these equations, if you add 3x to both sides and you add 3y to both sides, give us 5x plus 2y is equal to 0. So these equations are identical. So we've got one equation for two unknowns. So we can't solve these explicitly. We can't find a specific value of x and a specific value of y, and that's because there isn't just one eigenvector for eigenvalue, there's a set of eigenvectors. So now we know that this relationship must hold true. So we're going to write y into the vector x in terms of y. I'm going to say that minus 2y is equal to 5x, and we want to find some values that satisfy that. So if you take x as minus 2, let's say, so 5 times minus 2 is 10, and then you take y as 5, minus 2 times 5 is minus 10, so that satisfies that equation. So you put that in, and then you just put out an arbitrary constant t, where so t is anywhere from minus, that's an 8, terrible handwriting, minus infinity to positive infinity. Right, so that t multiplied by minus 2,5 is the set of eigenvectors corresponding with the eigenvalue lambda is equal to minus 3. Okay, so when lambda is equal to minus 3, anything where any vector that's a multiple of this vector minus 2,5 will satisfy this equation. Next up, we're looking when lambda is equal to 4, and that gives us 2x plus 2y is equal to 4x, and 5x minus y is equal to 4x, and this just leads us to the equations, sorry, not 4x is equal to 4y. This just leads us to the equation x is equal to y for both. Okay, because here if you subtract 2, you get 2x is equal to 2x, well that's it, y is equal to x, and here adding y to both sides you get 5x equal to 5y, it's just x equals y. So again, these equations are scalar multiples of each other. So now x equals y, well what satisfies that? 1. So our eigenvector is again t, 1, 1, and that's the eigenvector that satisfies, well that's the set of eigenvectors that satisfy the eigenvalue x equal to 4, or correspond to the eigenvalue x lambda is equal to 4. So that's it for this example. As I say, maybe in future we'll go through some, why we do this, what's it useful for. I mean, we've seen one use already. We found a whole set of vectors that when multiplied by this matrix just turn out as a scalar multiple of the vector, which is something we might want to know. So that's one thing, and then but we'll go a bit more into depth and why we do this. Maybe do an example with 3 by 3 matrix, but until then, that's it for this video. If you did enjoy, please like and subscribe, and I hope to see you in the next one.